This lesson we'll be looking at some further applications of simultaneous equations. So having a look at some worded problems that involve two unknowns. So what we'll do is we'll work through just two questions that are a little bit different, but both involve setting up simultaneous equations. So let's read this first one. The sum of the ages of two children is 24, and the difference between their ages is 8. If Nikki is the older sister of Travis, determine their ages by setting up and solving a pair of simultaneous equations. Now, the first thing we need to do when solving problems with two unknowns is to define a variable for each unknown. So the first step in this question is we can use x and y. Let's let Nikki's age be x. So let x be Nikki's and we can let y be Travis's age. Now it doesn't matter what variables you use. We could have used n for Nikki and t for Travis, but it's often easier just to work with x and y. So x Nikki's age and y Travis's age. Alright, our next step is to write down two equations from the information that we've been given. So we know that the sum of the ages, so the sum of the age of Nikki and Travis is 24. So we can write our first equation, x plus y equals 24, and let's call that equation 1. The other thing we know is that if Nikki's the older sister of Travis, and the difference in their age is 8. So if we have Nikki's age and subtract Travis's age from it, we know that that will give us 8. And now we've got two pretty simple simultaneous equations that we can solve. And we can either solve them by substitution or elimination, but given these particular equations, it might be easiest just to use elimination. So if we add equation 1 and 2 together, x plus x will give us 2x, y plus minus y will cancel out the y's. We'll get 2x equals 32. Divide both sides by 2, we get x equals 16. So we know Nikki is 16 years old. Then we'll come over here, sub x equals 16 into either one of the equations. Let's choose equation 1, and we'll get 16 plus y equals 24, so y equals 8. So we wrote down the two equations from the information given. We solved those equations simultaneously. And the last thing with these application questions or these worded problems is to actually interpret the solution and answer the question in words. So our final answer we can just write, therefore, Nikki is 16 years old. And Travis is 8. Alrighty, let's have a look at a question that's a little bit more difficult. At the movies, Jody buys 3 regular popcorns and 5 small drinks for her friends at a cost of $24.50. Her friend Renee buys 4 regular popcorns and 3 small drinks for her friends at a cost of $23.50. Find the individual costs of a regular popcorn and a small drink. So again, our first step is to define a variable for each unknown. Now, sometimes actually identifying what the unknowns are can be tricky. Our question clearly says at the end, find the individual costs of regular popcorn, so that's one unknown, and a small drink, that's the other unknown. So straight away we've got our two unknowns and we need to define a variable for them. So let's let the cost of popcorn be X dollars and let cost of small drink be Y dollars. Alrighty, so we've defined our variables. Our next step is to write down two equations from the information that we've been given. So let's look at Jody first. Jody buys 3 regular popcorns and 5 small drinks for her friends at a cost of $24.50. If we've let one popcorn be X dollars, 3 popcorns will be 3X. So our first term will be 3X. 5 small drinks, we've let one small drink be Y dollars, so 5 small drinks will be 5Y. And we know that that adds up to $24.50. Let's call that equation 1. Now let's look at Renee. Renee buys 4 regular popcorns, so that's 4X, and 3 small drinks, so 3Y. That adds up to $23.50. So we'll call that equation 2. So we've written down 2 equations from the information given. Our next step is to solve those equations simultaneously to find X and Y. So these ones are a little bit more involved than the previous question. We're going to need to do a couple more steps before the elimination. So why don't we aim to get these x's to become 12x. 12 is a common multiple of 3 and 4. The other option we could choose is to get 15y. That's a common multiple of 5y and 3y. But let's go with 12x. So in order to get 12x, we need to multiply equation 1 by 4. So if we take equation 1, multiply it by 4, we will get 12x plus 5 times 4 is 20y, which equals 2450 times 4 is 98. Now looking at equation 2, if we want to get 12x so we can do some elimination, we need to times equation 2 by 3. So that'll give us 12x plus 3 times 3y is 9y equals 2350 times 3, which is 70.5. Now this is looking a bit better. We can do elimination. I'll call this equation number 3. I'll call this equation number 4. Let's subtract equation 4 from equation 3. So 3 minus 4. 12x minus 12x, those cancel, the x's cancel. 20y minus 9y will give us 11y equals 98 minus 70.5 will give us 27.50. Divide both sides by 11 and we get y equals 2.50. Let's sub that in. Sub y equals 2.50 into, we can sub it into any of the equations. Let's sub it into equation 1. So we'll get 3x plus 5. Instead of y, we'll write 2.50. That's what we got for y, equals 24.50. Keep going with this. 3x plus 1250. 5 times 250 is 1250 equals 2450. Subtract 1250 from both sides. 3x equals 12. Divide both sides by 3. X equals 4. So we've solved the equations simultaneously to find an x and a y. Our final step is to actually interpret the solution and answer the question in words. So we found that x, which represented the popcorn, was 4. So therefore, popcorn costs $4, and small drink, which was our y value, was $2.50. So it costs $2.50. So there's a couple of questions that look at using simultaneous equations in some application problems or some worded problems. Hopefully that's been helpful for you.